We're back. Hope you enjoyed your break. We forgot to tell you, that's your chance to go to the bathroom,
Make phone calls.
get a cup of coffee, get a smoke, whatever you need to do. But that's what we just did. Oh, I didn't take a smoke, but yeah. But hey, let's bring it back, pull back together again. We're going to talk about line sets, okay? And as I said,
Could you ask for any questions? Sorry. Do you just want to, can I just cover one thing real quick? We did have a question come in at the end.
Yeah.
And it had to do with this presentation being available for future viewing.
Yep.
And I let them know it would be available on our YouTube channel. And Ron was kind enough to put the link to our YouTube channel on the chat. So if anybody wants to go to the chat button, they'll be able to find it there. And they can also search under Ferguson HVAC North Region. And now
correct. And I would say give us about 48 hours, 24 to 40. Yeah, it's not going to be because we have to wait for this to download. Then we have to send it off, and then it gets put onto the channel. So give us a few days, but I would definitely say by beginning of next week.
Beginning of next week, it should be there.
It would be there, and please feel free to share this at any point with any of your guys.
Right.
And that's why, so there'll be a part 1, a part 2. So I know that, Jim is he can keep count of what our breaks are time-wise, and we can do setting the unit, and now all of a sudden we'll get into line sets.
Mm-hmm.
So we're trying to keep it grouped together also so that we can break it up and it's more easily accessible to go right to a topic.
Right.
Okay. And so the topic now is going to be the line sets and mounting those line sets and routing those line sets. As we mentioned, we're starting off with a good base outside, a level unit. We're making sure that we're not stressing out of our pipe coming out of our unit. Okay, when we come into the house, okay, just what I want to say is this, guys. Think of how they're building homes today. Carpeting is not really the norm anymore.
Mm-hmm.
It's hard surfaces, engineered flooring, tile.
Mm-hmm.
So when you bring that line set, you drill the side of your house, and you're coming over the block wall, but then you got to get underneath that floor joist. Okay, we want to scoop down below that. We don't want to secure that line set right to the first joist, or we're going to get the harmonizing in that beam throughout the house. And it may not be there immediately, but when we've tucked it up tight and we used a clamp, okay, now all of a sudden in 6 months we've crushed the insulation on the pipe.
Right.
So what they're saying is that we need to actually suspend the line sets going in a basement or running in a crawl space and trying to isolate them, okay? Not necessarily, so whether it's a J-hook, whether it's perforated strap, some guys have used tie straps, but what we want to do is make sure that we're not securely putting that line set with direct contact to the wood, because we can get that harmonic sound going through.
Right.
Okay.
And if we attach that to ductwork, especially the metal duct, we attach that line set, now we're going to increase that harmonic, because now the ductwork's going to become like an amplifier. As we get that vibration, it's going to just amplify in the ductwork, come out the registers, and the customer's going to hear even more noise.
Correct. So that's it on the line sets. We're going to move into case coils, okay, and uncased coils, the air conditioning coil, and installing those. One of the concerns that we do have to have, and we have to understand that we are making a multi-positional coil, but depending on the orientation of that coil, we may need a kit to adapt it to the downflow application or to the horizontal application.
Right.
Okay, and you will notice also, all of our coils should be coming through pre-charged with dry nitrogen. And that is only going to be 8 to 12 pounds of dry nitrogen. And actually on the coils and on the air handlers, you're starting to see that there's a rubber plug.
Right.
And then it's shrunk wrap on there to hold that plug in, because in shipping, the rubber plug was hitting the cardboard. And so only 8 to 12 pounds is really only going to be a and then it's not
done,
right. It's done. It's not like the old days of when we used to stand back and brace the cap off and shoot it across the basement.
Right.
Yeah, those days, and then hearing that
Right.
And we knew, oh man, it's leak free.
Right.
Okay, there's very little nitrogen in it holding it, and so you need to make sure that, you may hear very little or none at all.
Right.
Okay, the location of the unit. Okay, and the reason I put this up is this, guys. This is probably the most confusing slide that guys will see in the install guide, and this is they don't think that it seems to make sense because normally setting in an upflow situation, the coil would come into the bottom of the A.
Right.
Now it's blowing into the bottom of a V.
Right.
And that is the correct orientation, and it can be done that way. And now you notice that our furnaces, per se, the top flange is what I'm going to call gender neutral. Okay? If we need it to be an upflow, we bend that flange outward, and it's now the male is coming out, and we drop the coil down in.
Right.
If it's laying horizontal and blowing right, we can take that flange and bend it in, and the coil can get a nice tight fit instead of it used to be a male, and then we had a screw around the edges. The other thing that you may want to mention to them, Doug, also is about the airflow.
Yeah, and we got to check our airflow as we look at our install manual, because if we're in that horizontal position, sometimes even upflow or downflow, we got to watch how many CFMs we're actually putting into the coil. If we put too many CFMs in, we might have water blow off. So as you can see, like on this 2-ton, let's say the very top line, in upflow and horizontal right, we can do 900 CFMs. But if we're doing horizontal left, our maximum airflow can only be 800 CFMs. So we really got to watch that we don't have water blow off, where that water or the air flows too much and the water just blows right off the coil.
Right, and one of the things that I will say is this, is that knowing in my mind horizontal left tells me then that we're blowing into the A,
right.
We're forcing all the air into the peak of the top of the A, and then the air is going to come out, and then that's where in those applications we put that splash guard
right.
into the ductwork
right.
to if in case some water droplets do go off, we shed them back into the coil.
And I think we show that splash guard on the next slide. Yep, right here, we show that splash guard you might have to install on that horizontal application.
And I would say this, Doug, again, guys, installers, please actually service techs. Okay, so you're out there, there's water in the drain pan. Why is there water in the drain pan?
Right.
We start, and I'm there like, what application is this? Horizontal left? Can you take the cover off the coil? Do you see the splash guard in there?
Right.
No. Well, what do I do now? My guys threw it out. We're gonna have to get another one.
Right.
So there is metal pieces that come with the kits or come with the coil. Do not discard them until you've looked at the install guide and done the right adaptations for that particular installation.
Right. One of the things we want to stress is even in the upflow position, there might be things that you have to replace, where you might have to replace the center baffle to get that maximum efficiency. So always look in the manual, get familiar with the product, your application, and how it's going to work if you're going upflow, downflow, horizontal left or horizontal right.
And if you're looking at that slide, I just want to bring that out. Also, look at figure 3.
Yeah.
You will notice that we're putting side baffles along that coil. That's usually in a downflow application. Right. Because what we're finding out, what we found out, guys, in the past is this. Oh, well, we get water dripping into the ductwork. Water's dripping down onto a coil, let's say, or however that orientation is. What's happening here? What happens is the airflow being pushed down the side of that coil, once they hit the very bottom and then come out, we're blowing the water droplets off there. How I was able to see this, and I'll just throw this tip out, guys, if you're ever dealing with water management issues and you're as a service tech and you're out there trying to look, one of the tools that I carry in my truck is a piece of plexiglass. I found that because when you take the doors off, you change the static in that duct system. Right. And now all of a sudden the water rolls down that pan nice and evenly, and you're like, what's the problem here? I can't see it happening. Put a piece of plexiglass on it and now create the same effect that the door had on it, and you watch with a flashlight, you'll see water blowing off and blowing around, and now all of a sudden you see what it is. That's what those side baffles are designed for in a downflow application. So again, be cautious when you're doing an install with a coil on the furnace that there are additional instructions for the applications.
And here we're just stressing again, here's some, on our 4PXC coil, here's some of the model numbers where they do recommend replacing that center baffle if you are in the upflow position. So again, we just want to stress that you're making sure you're watching the install manual for your install.
And one of the other things is this, the removal of the TXV when you're brazing. is mentioned here, and we want to make
The
sure.
bulb, the bulb.
Not the TXV, I'm sorry, the
Yeah.
sensing bulb.
Yep.
Okay, because we don't want to overheat that
Right.
gas that's in that sensing bulb. So we want to protect that. The other thing that we need to know a lot of, guys, is this. Okay, as we change and redesign the circuitry in a coil,
Mhm.
it is actually changing the targeted TXV operation and the superheat that we're looking for. So if you look at the slide that we've provided, where it says note, the TXV setting on this unit may run high superheat, 15 to 25 degrees by design, when measured at the outdoor unit. So what we're saying is this, so when you set up outside and you're finishing up your install, we would normally think like, oh my word, 20 degrees superheat. I wonder if oh man, do I have a bad
Starting to
valve?
get on the verge.
Yeah, and are we starting off
Yeah.
behind the 8 ball already? The answer is no.
Right.
And each individual coil may have, because we've been taught, rule of thumb, 12 to 16 degrees of superheat.
Right.
Now, all of a sudden, we're acceptable on this one coil of 12 to 15 to 25 degrees. That's a pretty wide
It's a
spread,
bigger difference, yeah.
depending on how warm it is in the house and the
Right.
circuitry of that coil. So we just want you to understand that. The other thing that they're pointing out in this picture is that there is a strainer
Right.
prior to the TXV. So if our TXV body, okay, if the tube is frosting up or the body of the TXV is frosting up, we know that we're flashing off gas before that. And a lot of guys will pull out a TXV and not even realize that there's junk on the screen.
Right.
And the replacement TXV is doing the exact same thing, and we're getting high superheat.
Right.
Coils on oil furnaces. We get asked this probably a few times a week, okay? And Doug just taught on that, on one of the ones that you'll find on the YouTube channel.
Right.
So maybe you want to just explain.
Yeah, just make sure on an oil furnace, remember on oil furnaces, we have that drum heat exchanger, right? And everyone always says, well, oil furnaces are hotter, the air's hotter, that's why you gotta raise that coil. Really what's happening, and the reason you gotta raise the coil is because of that drum is right in the center of our A, airflow is not able to get around the drum and up into our coil. So we need to separate. You know, some will say 3 inches. Make sure you're looking in the install manual, but the more the better, right? 3 to 6 inches is minimum for our airflow, so we can get our air up around that heat exchanger into our coil and get it up through and into the space properly. So, and also, guys, just because we're not working with oil, we're working with gas, doesn't mean we don't have to check the manual. With the FER requirements that happened last year with gas furnaces, we're seeing with some of our source coils, the ones that come with a piston, we're seeing that we have to add this metal heat shield underneath the coil to be able to protect it from if the fan would stop running before we go off on high limit or something like that. So they're looking for like a 400-degree temperature, and on our source coils, the material they're using for the drain pan, they're just a little worried there, so that's why they're having you put that metal shield in.
Right, and that can and that's usually field supplied. And I've
yeah,
actually,
it is a kit.
It is a kit,
Yeah.
but we will also give you the dimensions if you need to just cut flat sheet
Right.
metal on a job that you didn't realize you needed it.
Right.
Okay, that is also in that install guide.
Yep.
All right, so that pretty much wraps up setting the outdoor unit, doing the coil, putting it on a furnace, line sets, all of that. If there's any questions at this point, we'll entertain those. If not, we're going to move to working with an air handler. I'll just give a minute, or I'll just check with Jim. Is there any chat questions? As I said, guys, it's really important. So if you have any questions, feel free. Somebody said something?
Yeah, nothing on chat yet, but please unmute your mic at this point and ask a question if you have one.
Yep.
Okay, and actually, you can ask them anonymously. So, all right. All right, so what we're looking at, we're going to move into the air handlers, and we have to understand that not all air handlers are built the same. Okay, some air handlers are going to be positive pressure, some are going to be negative pressure, some are the metal cabinets with the batting insulation inside on the foil paper, and then some are our new composite air handlers, and we'll go over those with you.
That TEM4 is our standard air handler. Yeah, and everyone has seen an air handler like this who's worked in the industry any length of time. It's a metal cabinet. We have it insulated. We have the coil on the bottom, the blower, and then your heat strip. That coil, all our coils on the TEM4, TEM6, or TEM8 air handlers, they all do have a TXV for metering device. The differences between the 4, the 6, and the 8 is on the TEM4, we either have a PSC motor or an ECM constant torque motor. TEM6, we have a variable speed, 16-wire variable speed motor, and TEM8 is actually our communicating line.
Correct, and then those matchups, ratings, really depend on some of the outdoor units. So if you're gonna get a 2-speed air conditioner, you're gonna wind up having to put it with a TEM6 because of the variable speed motor being able to obtain 2 different settings of airflow.
Yep.
They are also multi-positional.
Right. So you are able to put those in upflow, downflow, horizontal left, horizontal right, but there's going to be some changes required as we make that adjustment, and you're going to want to follow the install guide to make sure that you're doing that adjustment properly, that we're getting the right positions.
And then the big question, and sometimes the complaint, honestly, is where do I put the filter?
Right. And on the TEM4 units, there is no filter spot in the air handler itself. You are going to have to put an air filter in somewhere else in the system. Now, guys, one thing that I personally like that there's not one here is because most times that filter spot is not designed for a high efficiency filter where someone goes out and says, oh, an allergen filter, it's a 1-inch pleated allergen filter. A lot of times those filters do have a high restriction and the units just aren't designed for that high restriction. So make sure we're sizing our filters properly as we install them in our systems.
All right, I don't know if somebody unmuted. Is there a question? Sorry to call you out, maybe a little hesitant, but if there is a question about that, please feel free.
Yeah, I don't see anything, John.
Okay, so then we have the TAM9 air handler and the TAM4. They are our 2 most common composite air handlers. They are now going to be positive air pressure.
Correct.
Because the blower's on the bottom, we're pulling our return air in and we're pushing it through the coil. These particular units are going to have an electronic expansion valve on them. I don't know if there's anything else, Doug, besides, well, I guess one of the nice things about this particular unit is it's 4-way positional.
It is 4-way positional out of the box with very little modification. When you look back at that earlier picture, you could see when the door was open, you could see our horizontal drain pans are built in right into the cabinetry. We have our upflow drain pan and we have our downflow drain pan built onto the coil right away. So right out of the box, this thing can go in any position with hardly any change. None of what's changed is if you do go horizontal, we do recommend putting the screw here on the coil so that coil is held in place in that V shape rather than just starting to sag depending on which side you put it on. It'll make getting the door on and off a lot
Right,
easier.
because I can tell you, most guys that are laying on their side with a flashlight in their mouth, with their phone, are griping to me about these doors are the worst thing to ever put on. I can't stand it. Who designed this? Well, do you have a screw in the coil? No. Put a screw in that coil now.
Right.
Oh my word, it goes on, it doesn't fight me to line it up.
Right.
Because realistically, you're getting the door on and you're trying to lift the coil, the stress of the coil, with the door.
Yeah. Well, and one of the things we're going to mention too is because this is a positive pressure air handler, it is going to be normal now to feel a little bit of air coming out of some of the gaps on the door. And that's normal. This is meeting the requirements for minimal air leakage. The biggest difference is because it's positive pressure, we can actually feel that leakage, where before on the negative pressure air handlers, you can't feel the leakage. You can't see the dirt and everything that's going in bypassing the filter, where now everything is actually going through the filter. Maybe we have a slight leakage of air coming out, but it's not going to cause harm to our system.
Okay, so I'm going to stray here for a minute, Doug, only because it's so applicable to this situation. So when you put the composite air handlers in, the TAM family of air handlers, okay, we are dealing with the TAM9 with a serial port motor. That motor has the ability to push the airflow that we programmed into it, even up against high static.
Right.
Okay, but when we raise the static or our ductworkers resist it, we will get more leakage out of that unit around the water hole, around venting, around, different areas, the doors, things like that. So one of the things that we want to make sure is that we don't restrict airflow going into this unit or going out of this unit. So what that means is this, that if I were to look at the top of my unit, if I had a 18-inch wide by 18-inch deep hole on the top of that unit, and I'm just throwing a measurement out, I don't want to wind up panning off 4 or 5 inches so that that ductwork comes straight in on the top. That panning now is going to back pressure and raise my static. That air that it's creating has to go somewhere. If it can't go in the ductwork, it's going to leak out the doors.
Right.
And so you will actually feel more air come out. And with the TM9s, the CDA allows us to go in and see actually what our airflow is and what our static is.
I went out on a job site like John's talking about, and the ductwork was restrictive, and they were actually complaining about water coming out of the door itself. And when I looked on the CDA, saw the static pressure, we were at 1.3 inches. You know, the unit's just not designed for that. The blower's doing everything he can to push the airflow, but ductwork was restrictive, and that's what was causing the issue.
Particularly in a horizontal application.
Right, and this was a horizontal, yep.
The nice thing about this particular unit is it is modular. Every part can be pulled out. The units pull out on a rail, very similar. You know, how many of you guys fight with pulling your produce drawer out of a refrigerator? You don't. And it just slides. This particular unit works that same way. Each component is able to be slid out and carried into the attic. Actually, the unit can break apart into 2 sections in the length.
Yep.
And all of the components can come out, and you can actually take the ends off of it so that you can C-roll it.
Right, up around that attic access door?
Correct.
Yeah. So it makes it really modular, honestly, and as far as being able to break it down, right, and to put it into that modular place, to put it up in an attic, guys who do this all the time can do it under 20 minutes. Tear it apart, put it up in the attic, put it back together in under 20 minutes. So it's really, really handy to be able to use this unit up in an attic space where you got tight access.
And I know there's some older guys sitting out there. So if you remember the days of a TWE, you know, like 030, you know, P or whatever E unit, I used to stay in a driveway, and it was over an hour and a half to take the coil out, to take the brackets out, try to pull the metal cabinet in to create a V, to get it up, and then reassemble it totally in an attic. You know what I mean?
Yeah.
Now, like,
it's a piece of cake.
An hour and a half compared to 20 minutes.
Because between these 2 sections, what holds that together is just a cam block. So you use your Allen key, you can open it and shut it. It's a really tight, solid fit. It works really, really well.
Correct, and I really do like that. The unique thing about this particular product, again, because we're taking the variable speed motor and we're getting better efficiency out of this unit, is that we're using an electronic expansion valve.
Yeah.
That's pretty much where we're going to leave it at this point right now. In the service side of this, we're going to dive into this a little bit more.
The EEV and how they actually function. Again, when we charge, just as a reminder, on charging with an EEV, we're going to charge to subcooling.
Correct.
Yep.
And with that, I will say this, you should be able to get a nitrogen flow through that. That's oftentimes a question that guys will ask. The valve is not going to be in 100% closed position. We should get some leakage. It's going to be slow, but you should be able to get some leakage through. If there's ever concern, guys, you can always pop the stepper motor off the here, take the black body off of that valve that you see to the right on your screen. And you can actually take a pickup tool magnet if you need to and run it around the body and manually open up that valve, okay, if you need to. Or if you power it up on the board, you can go test to open and then pull the stepper motor or kill the power at that point. And you'll hear the nitrogen rush through. Okay? The nice thing about this unit is that you can cut into it for a return, which we will show you, but there are certain areas that we need to make sure we stay away from.
Because of the design of the composite and the modular ability, we actually run our wires through the side of the unit. So they're encased in the foam. So we have to be careful that we're not cutting a wire, we're not running a screw into a wire depending where we're doing it. So we have to follow the guideline to where we can actually penetrate into the system.
With that being said, one of the things that came up in a question the other day in teaching this was this. You guys, I noticed that there's no more knockout.
Right.
Okay, for the electric to get into the unit. That is true. In the past, we had a pre-punched out area. Right. But what happened was that we were figuring the biggest wire that we would have. which was, let's just say, where we would need a Romex connector of 1.25 inches.
Right.
Okay, well, how many of us guys have bushings back down? And then when we started adding the bushings, we couldn't get our
Connector together, and
Yeah,
it
the
would
connector-
be loose, and it wouldn't be a good seal.
So now what
Yeah.
they've done is the backside of the internal part of the fiberglass composite
Mhm.
has been notched for something that large, but the outer cabinet has a starting point
Right, you can see that starting point right here by this little dot.
either on the side
Yep.
of the unit or on the top,
top.
and you would take your uni bit
Right.
and then just drill the particular size hole, whether it's a 1/2 inch Romex connector
Mhm.
or a seal tight connector, 3/4, whatever you desire, you want, you can get a nice cleaner, better application
Right.
for that. Now, we can get a side return in on the
Right,
unit.
because that blower is on the bottom instead of in the middle, we are able to do side return right into the blower, just like we would on a furnace. We do have limitations because of the design of the air handler, how big the hole can be. Because of those limitations, we're only able to go up to 1200 CFM on one side, as you'll be able to see on this next slide here.
Well, I'm actually gonna go back a
Oh,
step.
you wanna go back? Okay, yeah.
Okay, only for this reason, guys, if you're looking at this picture, one of the unique features about this particular air handler is this. Okay, think about this. We don't have to get it up on a plenum box. So you
Right.
got an old
That's
townhome,
true,
or
yeah,
you're in the
good point.
city. Okay,
Yep.
you could be in Philadelphia, you could be in Harrisburg, Lancaster, downtown row homes.
Mhm.
Okay, small head banging basements. Now I can put that air handler right on the floor,
Right,
okay, and then come in on the side.
right. And because of that, if you have up to 1200 CFMs, we can go into just the side of the unit up to 1200 CFMs. As you notice here in the picture, your filter is away from the unit about 6 inches. That hole size is pretty small, and because that hole size is small, we have to have access that your filter is size large enough, and that we can step away from that access hole. As we go through that and we transition there, again, your filter is going to be larger than an access hole, so we need to have the space for our air to come through our whole filter, not be restricted, and then come into the side of the unit.
Okay, I did get a text here. I don't know if Rick Blank, one of our other FSRs that's part of the Ferguson team in Ohio, wanted to unmute and make a comment about the nitrogen flow through this particular unit. Rick, did you want to do that? And we're glad that you're part of the group today.
Yeah.
Good morning, John and Doug.
Good morning.
Thanks for the invite. Yeah, on any heat pump coil, if the TXV or the EEV is in the closed position, we should still have the ability to flow nitrogen in the suction line or the large line and out the liquid line, because the internal check valve on the TXV or EEV should allow it to flow.
Very good, yeah. So that is a good point, because all of our TXVs have gone to, and particularly the EEVs that we're now using, are internally checked.
Right.
So therefore, we do allow a bypass of that refrigerant to come through there. So that does bring up a really good point.
Yep.
So depending on which line they're putting the nitrogen in first, we should be able to get that through
Right.
the unit for purging. And I appreciate that.
Yeah.
Rick's a great guy out in Ohio. I know that we're really happy to have him part of the team. Actually, he
does come in and do trainings for us in line north here.
Right, and he was a great mentor to me when I first stepped into this role back in 2009, and I went, what in the world do I do? And they said, we're gonna bring Rick in, and you're gonna shadow him for a few days. And I really learned a lot. And
Yeah,
about
I remember
teaching and PowerPointing.
I remember taking classes that Rick taught as a young technician as well, so he's definitely influenced a lot of us.
Correct, and so we're glad you're part of us, Rick.
Yep.
You'll have to give us an honest critique later.
Hey,
Not
thank
too
you for
honest.
Thank you for the kind words, and you guys are doing a great job.
All right. So one of the things is, and the reason that we talk about this transition, guys, is this. Okay, think about this. If that hole is only, and I can't remember, 11
by 15, I think.
right.
Yep.
Slapping a 16 by 25 filter next to 11 by 15 hole is really not using the maximum size of that filter, particularly if the consumer is going to run down and then start buying that high pleated filter.
Mhm.
We are going to definitely have restricted airflow, raise the static pressure, which causes another whole issue of service
Mhm.
on the unit. Okay?
Now,
And then-
yeah, if we are doing horizontal, we got to remember we got to field supply pan that bottom of the unit off so airflow can't go up through it.
if we're sitting there on the floor.
I'm sorry, yeah, if we're doing side to side entry.
But actually, one of the things and he mentioned horizontal, and I will say this,
Right.
I have seen this application be in an attic, and they didn't have the space behind it because of the tightness of the attic, and so they've actually pushed the unit to the end, put the end plate, and laid the return on top of the unit and across the supply. To get over to an area. And so it can be done that way because we have side access, good for, now, whenever we do something like that, I do want to say this, turning vanes are a wonderful thing to help the air and keep the static down.
Yeah.
Okay? If we go over 1200 CFMs, which these air handlers can do, I will say this, every one of these air handlers, if it's a 4-ton, 5-ton, 3-ton, they can take their maximum airflow 100% straight through the bottom.
Right.
But if we're restricted and we're coming in on the side, we only have to lift the unit 6 inches up in order to get the balance under the bottom. And we do sell lift kits for this product.
Right. And we want to make sure, again, that our filter is sized properly. We have that distance away from the unit from our filter to the return so our airflow can get around into the unit properly with as little restriction as possible.
Okay, and then basically running a trap on this, okay, is optional.
Right, and I know when we first started installing as a technician, the TAM 7, which was the predecessor of the TAM 9, we put it in our first attic job. We thought, oh, this is awesome. We don't need to run a trap. We don't have to worry about that trap freezing. Well, we had issues because we didn't insulate that line. So if you don't insulate that condensate line, and you don't have a trap, it will sweat depending on the application you're running it. In an attic, it will sweat in the summertime. So traps are good because of that. But again, if you don't use a trap, please make sure you insulate the line so that you don't get condensation on that condensate line.
And I will tell you this too, that if you're going to run a trap, it must be, because of the variable speed blower, we want to come out, drop down 4 inches, come back up 2 inches, and then run gravity. We do not want a running trap.
Right, running trap will just blow the air right through that trap. There'll be no water in the trap, and it won't help us with the condensation.
Correct.
So.
Okay, connecting the ductwork to the air handler. Again, remember, it is a fiberglass, somewhat composite on the top ring. We want to use a short 1/2 inch, 3/4 inch screw, but we don't want to use our impact wrenches.
Right.
Okay, we want to, if we do, we want to dial that down so that we're not ratcheting that screw.
Because it's easy to strip it out. Right.
Correct. So when we get into the unit, okay, so the transition here is this, guys. We've done either a furnace or we've done an air handler on that outdoor coil. Now, what becomes really critical, and this plays a major role in the performance of the equipment and possible service future work, is this: knowing what blower you work on and knowing how to set the proper airflow in that blower. This is one of the biggest areas that we find ourselves, because I'll tell you this, if you don't know what the airflow is that's in the unit, or you don't know the defaults, okay, it will affect the way you charge the unit. The way you charge the unit is going to then affect something down the road, and you'll get next season a phone call, or if it's a heat pump, come fall season, all of a sudden this unit's tripping out on high pressure. Well, how did that happen? And you and I, as FSRs, we start with that service tech going back and saying, okay, what air handler do you have? Oh, that's the one with that particular motor. Let's go in and check either those dip switches, those wiring connections. Let's go back and make sure that it was set up right. And normally we find out that if airflow wasn't right, so therefore, once the airflow is not right, we just snowball in a bunch of other mistakes. Okay, so we do want to take a few minutes and go over setting airflow. So why don't you just introduce this?
And it just depends on what type of blower you have, depends on how you're going to configure airflow. If you use one of our Nexia thermostats, you're gonna help configure some of the adjustments of airflow from the thermostat. Potentially, right. Or the 16-pin connector variable speed in the TEM6, we're gonna set up dip switches. On the TAM 9s, we're gonna use our CDA to set up that airflow.
Right, and so what are we really trying to control, okay? Why do we need to understand the blower? Okay, airflow is going to be different if we have a single speed piece of equipment.
Right.
Because we want 100% of the total CFMs that we need through that unit at the beginning.
Right.
So if that particular unit is a 3-ton unit and we've determined 400 CFM per ton, we want 1,200 CFMs to be available during its normal operation right away.
Mm-hmm.
Okay, if we have a 2-speed piece of equipment, we have to understand how are we going to handle 2 different airflows.
Right.
And we're going to have to do that. If we're dealing with a variable speed product, okay, an inverter outdoor product,
Mm-hmm.
okay, that's going to be totally different.
Right.
Okay, and when we see this here, understanding the variable speed motor and what it can do. Okay, but what are we trying to control? Single stage, 2-stage, or possibly variable.
Mm-hmm.
The other thing is that oftentimes you'll see in ratings, oh, a TDR to get a SEER rating. What does that mean? It's a time delay relay. Well,
Right.
is that something I'm adding to the unit? Is it something I'm setting up in the thermostat? We can discuss all of that. Usually it's something in the thermostat.
Right.
What else are we controlling with airflow? We'll talk about comfort R.
Right. On the variable speed product, you'll see either comfort R or enhanced mode. Could be
Right.
called either way.
And every one of the units, whether we use our control or a third-party controller, we're going to be able to do time delays after a call.
Right.
Okay? And then we will take a few minutes and talk about wiring up the G and the BK on new stats and why. We'll verbally mention that. We don't really get into that right now because it's kind of the 101, but we can
Right.
talk about it for a moment.
Our lights went out because we're not moving enough. So on the blowers, we have to configure the blower, and the basic standard blower, like on a TEM4, is a 3-speed PSC blower motor, as we'll see in the next slide here. And normal adjustment on that is either going to be, you take the wire, if you're on low, you move it to medium, or you move it to high. On the TEM4s, it could be 3 wires that are sticking up that'll tell you have to adjust the wire to the certain fan speed. As we look at that, we got to look at the actual airflow chart on the unit. And as we look at the airflow chart, the biggest thing we want to point out is this little plus sign that shows that the factory setting is on low speed. So if we have a 2-ton unit, here we can have a 2-ton air handler on low speed. If we have any static at all, like at a 0.5, we're only going to be at 505 CFM. So we are going to have to adjust that fan speed to medium or high.
Correct. So again, this is what I'm saying. So when you look at this blower housing, okay, the blower motor size, horsepower wise, the blower wheel size, the blower housing is the same in an 18,000 BTU unit, a 1.5 ton
Right.
or a 2-ton. That's a difference of 600 to 800 CFMs.
Right.
So we have it predetermined that it's on low. Okay, probably because of the ratings of 350 per ton.
Right.
Okay, and then we're looking at 2-ton unit or a 1.5 ton, and it's in there. What we have to understand is that we have to understand that's there. So what would happen, guys, is this. You call me up and you tell me, hey, John, I'm looking at this unit and the charge doesn't seem right. I'm actually running a little bit low. Should I throw some more charge in here? And the answer is going to be like, no, whoa, whoa, whoa. What is your indoor unit?
Right.
Well, I don't know. We need to know.
Right.
Because if you start saying, oh, it's a TEM4, my first thought is, can we go inside and validate the airflow setting?
Right.
And then we realize, wait a minute, it's on low. The low airflow dropped the coil temperature, which reflected itself in a low suction temperature, which made the last guy think he needed to overcharge it.
Right.
Okay, or didn't charge it at all and just walked away because he just weighed in his charge and thought he's good to go.
And yep, didn't even look at it.
Correct. So what we're just saying is on this, you need to go back and look. So realistically, if we were to obtain what we think normally would be our airflow with any kind of static, we're actually changing that wire from low to high.
Right.
Okay, and that is important.
And then we have our ECM constant torque motor. It's like a PSC motor where it's a fixed speed, but it's a little more efficient by having the ECM motor.
And that's going to look a little bit different, and usually that's a change in moving the actual tap. The
Right.
PSC motors, we've run 3 wires out of the motor housing so that you don't have to get down in there and try to move the
Right.
wire in the taps. We change it in the electric compartment. On these units, it's a visible and open, it's a little bit longer of a motor because of the module on it, and then the changes.
And then you'll see that taps 1, 2, and 3 are all the same fan speed as low, tap 4 is medium, and tap 5 is your high fan speed. And you can see that on the wiring diagram as well. So as you follow this green wire, it's the green wire that connects all the way up here with our thermostat. So that unit gets brought on by that green wire, that's our fan speed, and that's where you're going to adjust it. And the same thing, we're going to look at the speed chart, our airflow chart, to know what our static pressure is, to know what fan speed we're running at, to again get the right CFM for our system.
Correct. And even in that situation, again, look at where the star is at.
Yep.
Even with that torque motor, that's a better motor, it's still set on the low airflow setting.
And make sure to look at all the notes, guys. One of the things we want to show is if you look at note number 5, again, it's saying that at air handler in the downflow application, if we have more than 1600 CFM, this is a 4-ton unit that we will have condensate blow off. So we just got to make sure we're looking at our fan charts to know that we're setting our units up properly.
Right. And so so this is what I'm saying. So again, I know it's an installer, an extra step for the installer to really evaluate and look at this, but he's going to come off looking a lot better if he did this, because if not, then the service tech who's out there saying, okay, it's a water management issue, his first thought may not always be, oh my word, let me check the airflow and see what tap they're on, thinking that hopefully the installer did it.
Right.
And so, it's something that we need to look at, and not many times when you think water management, oh, airflow tap.
Right. And then we go to our variable speed blower motors. And again, depending on which variable speed blower motor you have, you're either going to have dip switches or the CDA, if you could change. And here you can see the board that you're going to have to adjust. If you have the 16 pin, we can see our 16 pins here for our variable speed blower motor. We're going to adjust on our dip switches, or on our TAM9, we have a serial port blower motor, and we're going to use our CDA to adjust our fan speed.
Right. And so what we're doing is we're going in and setting certain parameters.
Correct.
We're setting actual CFMs according to the information that we're giving it.
Right. And as you can see on the dip switches, they're not set for every application again from the factory. We're going to see that through dip switches 1 through 4 are going to control our outdoor units tonnage and airflow CFMs. 5 and 6 is going to be our fan off delay, and 7 and 8 is going to be our auxiliary heat fan speed. So again, we're going to go back to our chart, and we're going to look at our airflow chart, verify our static pressure with the airflow chart. As we look at this chart, if you have a 2-ton unit and you want to set that 2-ton unit up for 400 CFMs per ton, we're gonna have dip switches 1 through 4 off, on, off, off. And that's going to get us that 400 CFMs per ton. So again, just follow the chart, follow the dip switch settings, and you guys will be in great shape.
Right. And then we want to talk about dip switches 5 and 6, because this is, if you have a variable speed system, and even without the Trane or American Standard thermostat, there is a really nice feature that's available if we know how to set the dip switches.
Right. And really setting that dip switches really helps. This variable speed, the enhanced mode, if we do 5 and 6 to on, it really amplifies the operation and really enhances our reason of having a variable speed motor. So when you get a call for heat, a call for cooling, what's going to happen is in that first minute, our airflow is going to come up to 50%. So if we're running a 3-ton unit at 1200 CFMs, we come up at 600 CFMs for that first minute. What's happening is our coil in cooling is cooling down really quickly, right? Or our coil in heating is heating up really quickly. And the advantage of that, especially on the heat side, is customers always complain about heat pumps, that cold blast of air that comes out of the registers when it starts up. This is going to help take care of that. After that first minute, our airflow is going to go up to 80%. On that 3-ton system, we're going to be about 1,080 CFMs. And what's going to happen during that is we're going to dehumidify better because our coil is going to be colder in air conditioning, and we're going to have warmer air coming out of the registers and heating because our coil is going to be warmer. And then as that runs for the next 7.5 minutes, if it doesn't satisfy the call, then we go to that 100% airflow. So after 8.5 minutes, now we go to 100% airflow until we satisfy the demand. After we satisfy the demand, the unit's gonna, and the call is done, our blower's gonna ramp down to 50% for the next 3 minutes just to, again, get rid of that cold blast, but to push that paid-for air out of the ductwork into the space.
And so where the rubber meets the road for the installer is this. So if an installer says, "Ooh, I sat in that class, I remember, ooh, I want to give these people really good dehumidification.
Right.
So I'm going to take 5 and 6 switches, turn them on."
Mhm.
Okay, think about this. Then our normal routine would be to go down, crawl out of that attic, we walk by the thermostat, we push it to cool, we drop the temperature 10 degrees, we go outside and we got our gauges on and we look at it and we go, "Oh my word, I'm low. Hey, Joe, get me the jug.
Right.
We're going to have to put refrigerant in here." And all of a sudden, as you're looking at it, wait, whoa, wait, hold on a minute, wait a minute. It's coming up a little bit. It's coming up a little bit. Well, what just happened there? We had 50% airflow for the first minute.
Right.
Now, all of a sudden, we're going to run at 7.5 minutes at a lower airflow, and we're going to almost get there.
Yep.
And then if we wait long enough, after about 10 minutes of runtime, that coil's wet enough,
Yep.
airflow is happening, everything's right, superheat is now being established. We can now check our charging on
Right.
that unit.
And you always hear wait 20 minutes, and I know as a technician myself, that seems like forever, but it's really important if you have the enhanced mode, because it will throw off your readings if you don't wait at least that
Don't jump
10
the
to
gun.
15 minutes. Yep.
Don't jump the gun.
Yep. And then again, for our 7 and 8 is our auxiliary heat settings on that air handler. And again, you want to look at your manual to know what auxiliary heater you're putting in, to what airflow is required, to where you need to set your dip switches. So just follow the manual.
Some of the units will have a communication display assembly. This assembly is a really good tool. It is not only, it replaces the dip switches, so it allows you to make changes in the profile of this unit here. Okay, there, I'm going to put up a chart here as you look, and we're not going to take the time today to go through every one of these. But from this particular unit, first of all, if you hold your upper and lower buttons, north and south,
Yep.
okay, simultaneously for 10 seconds, it will switch and say monitor menu. From there, you can go down and you can see your stepper motor, your temperature of your coil, you can see your airflow, you can see your static, you can see your superheat. There's a ton of readings in there that help for
Right.
diagnostics, okay? You will also be able to have your alert menu,
Right.
a history of all the faults that have happened actually right inside that unit.
Mm-hmm.
So if there's any issues, airflow-wise, blower-wise, communication-wise, sensor-wise, it's going to all be listed in there. And powering up and powering down does not lose those faults.
Right.
Okay? The next menu would be configuration menu.
Right.
This is where you'll go in and you will tell it whether it is a single-stage piece of equipment. Well, first of all, it says, what kind of outdoor unit do you
Right.
have?
Do I have an air conditioner or do I have a heat pump?
Correct. And depending on that, will set you up. So if you say air conditioning, you're going to go down one trail of questions.
Right.
If you go heat pump, it's going to bring you another trail of questions.
Yep.
Okay. And the next question is, okay, so then air conditioning, yes. Is it single stage or 2-stage?
Right.
Now, it doesn't actually ask you that question, but what it says is ODU, outdoor unit, is it a 1-1, which means single stage, 1 compressor? Is it a 2-1, 2-stage single compressor, or a 2-2? Meaning 2-stage, 2 compressor unit, which is for a retrofit of
Right.
our old 2-stage unit. The biggest situation that takes place in this unit, depending on whether you're putting straight electric heat in, or if you're doing a heat pump with auxiliary backup heat, is you want to make sure that you program this unit to say what size electric heat you have.
Right.
It starts off in what they call a parked position. If that unit says all of a sudden that my W's are energized, but you told me I have no electric heat, well, how can I turn on what I don't have? Therefore, I now have a fault.
Right.
And it's going to give that. And then it also asks you for your KW, and you need to tell how many KW, because then it's looking for not every W1, 2, or 3 gets hooked up,
Right.
depending on how many contactors.
If we only
you
have a
to
10 kW heater, we don't know we only have 2 banks of heat. So if we have W3 hooked up, we're going to get an alert saying it's calling for more heat than what it's configured for.
Correct.
Yep.
And so there's just a whole bunch of information there. And in the control menu, you can actually go in and run some tests, such as like you could do your EEV valve.
Right.
You can do some different things that are available in that.
Right.
Okay?
So at this point, it brings us to the end of our air handler section. We just want to make sure, does anybody have any questions before we take a break?
Air handlers and blowers.
Yep.
Yeah, the only one on chat, until anything else comes in, is we just got one, and it has to do with the press fittings that we talked about earlier. And they're asking how would we use that on our condensers and coils because of the what they call the bells, the expansion. And
Right.
Okay.
my opinion, quite frankly, is Train recommends braze. So anything you do other than that, you're on your own.
Correct, but I will tell you that in addressing that question, is this, that if you were to get a smart lock,
Right.
okay, actually, I have sorry about this, and it's not an advertisement, but there is something called smart lock,
Yeah.
okay? And I don't know if that actually works. I don't know if you can per se see that.
Yeah, that's quite good, really. Like that.
Yes, but that smart lock does have what they call swedge
Right.
to pipe.
Right.
So if you have a 7/8 fitting, it's going to be swedge, which goes
Over the bell.
Right. And then allows the pipe to go in.
Right.
The only thing that I would say is this, guys, is this. You all have known that when you braze, you put a piece in and you start to heat it up, you will watch there's movement.
Right.
Okay, you cannot have, when you're using these smart lock fittings, mechanical fittings, you cannot have stress on that line where it's going to want to pull out.
Right.
You know what I mean? Like you can't shove it that little bit or have somebody hold this end while you do this. Because what has to happen is without any tension, that's a good, I think the right word.
Right.
Without any tension on that, you would slide this over. You have to seat your pipe, making sure that it's a nice flush, flat cut in there, and you hold that, and then you start tightening up because it's going to want to walk.
Right.
Well, if there's tension already on it and we're pulling on that, eventually we're going to set ourselves up for a blow-off failure.
Right.
So you have to make sure that you follow the instructions. And smart lock, if you chose that particular manufacturer as a mechanical fitting, which we sell, they actually have a series of videos that will teach you how to properly put it on so that there isn't a leak or a failure. And those smart locks come in copper to copper, swedge to copper, and flared to copper.
Right.
So that you could use it on ductless or wherever there would be a flared fitting.
Yep.
Okay? So I think that kind of addresses that question. At this point, we will take a break. We'll come back again then at 10:15-ish, right around there, and we'll get started on understanding the controls, and then after that, we'll move into service. All right, thank you very much.